Example 5. Let's consider a dice game in which you receive 50 points for rolling a 6, 5 points for a 4 or a 5, and nothing for a 1, 2, or 3. Find the expected value and standard deviation of the game. So let x equal the points awarded. Now we're going to do a probability table, the model. So we have random variable on top, the probability of the random variable occurring on the bottom. First thing we can do is win $50. That requires getting a 6. There's 1 6 out of 6 outcomes on the die, so 1 over 6. Winning $5 can be a 4 or 5, so 2 out of 6. And winning nothing, you can do that with a 1, 2, or 3, so 3 outcomes out of 6. So the expected value of our random variable x, so e of x, equals 50 times 1/6 plus 5 times 2 over 6 plus 0 times 3 over 6, which comes out to be 10. So now let's find the standard deviation of x, which will be the square root of the variance. So the square root of 50 minus the expected value, 10 squared, times the probability of winning 50, 1/6, plus 5 minus the expected value, quantity squared, times 2 over 5, times 2 over 6, plus 0 minus the expected value of 10, quantity squared, times 3 over 6, the probability of winning 0. This comes out to be 18.0278. So our expected value is 10 points, and our standard deviation is 18.0278 points. So what happens if we double the points awarded? Now you're getting 50, 10, still 0. Well, now we're just doubling that expected value. So e of 2 times the random variable equals 2 times the expected value of x, which equals 20 points. The standard deviation of 2x equals 2 times the standard deviation of x, which will equal 2 times 18.0273. Which is going to be 36.0556 points. What if we play the game twice? Now instead of doubling it, we're playing twice. This is a little different. The expected value of x plus x, because we're playing it 2 times, equals the expected value of x plus the expected value of x. So we get 10 plus 10, which equals 20 points. So far it looks like the same as doubling. But our standard deviation will be a little bit different. The standard deviation of x plus x equals the square root of the variance of x plus x, because of course, as we know, variances add. I can't add standard deviations, I have to go to the variance. Now we found this in the previous problem already, The variance is actually 325 for x, and we're doing it twice. So the square root of 325 plus 325, which is going to equal 25.495 points. So if you noticed, playing it twice actually lowers the standard deviation versus doubling the points. So there's less variation when you play it over and over again. Okay, suppose you and a friend both play the dice game. What are the mean and difference in your winnings? So slightly different here, expected value of x, y, so you minus your friend will equal 10 minus 10, which is 0. You still have the same expected value for both you and your friend. So there should be no difference on average. The standard deviation of your winnings minus your friend's winnings will equal, again we have to put it the variance, and variances always add. So the variance of your winnings plus the variance of your friend's winnings will equal the square root of 325 plus 325, which is going to come out to be 25.495 points.